Hey guys, welcome to Empower Education. I am Prasanna, and in this mini video we are going to see what do you mean by polynomials. So polynomial is a very important topic, so stay with us, and if you like our videos, please don't forget to share and subscribe. So let's see what do you mean by polynomials. So as the name suggests, poly means multiple and nomial means terms. So an algebraic expression which will have multiple terms is called a polynomial. So what do you mean by multiple terms? Let's consider this. Y is equal to x plus 3. Here x and 3 are two different terms. So we call this a polynomial. If we say y is equal to x square minus 5x plus 6, is this a polynomial? Yes, it has a multiple terms. Y is equal to x cube plus 3, is it a polynomial? Yes, this is also polynomial, it has multiple terms. But what about y is equal to root x plus 3? Now, is this a polynomial? No. In order to be a polynomial, the power of variable should be natural number. तो ऐसा सब कुछ नहीं चलता, root 1/2 raised to the power 3/2, ऐसा सब कुछ नहीं. We want the power as natural numbers. Now, there is some characteristic of a polynomial. It called it the degree. So, what do you mean by degree of a polynomial? What is degree? Degree is the highest power of the variable in polynomial. So, consider a few examples. Let's say y is equal to x plus 2. What is the highest power of x here? Highest power of x is 1. So, we call it a degree 1 polynomial. So, it's a linear. Another example, let's see y is equal to x square minus 3x plus 2. Here, degree is equal to 2. So, it's a quadratic polynomial. Let's consider another example, y is equal to say x cube plus 3x square plus 2x plus 11. Here, highest power of x is 3, hence degree is 3. So, it's a cubic polynomial. This is what we saw about the degrees. They have different characteristics like graphs and roots. So, let's see them one by one. So, linear polynomial, its zeros and its graphs. So, let's start with an example. First of all, let's see what is the zeros. So, for a polynomial, a real number k is said to be a zero of polynomial p of x if p of k is equal to 0. Yeah, it's hard to understand this way. Let's see in the simple way. So, 0 or root is basically that value of x for which the polynomial becomes 0. So, if you put x, the value of y should be 0. This is the very simple basic term for the 0, or also it is called a root. Now, let's see one example. If I say, let's take a linear simple equation. Let's say y is equal to x plus 2. Now, here, if we keep putting different values of x, what do we get? If I put x is equal to 0, y will be equal to 2. If I put x is equal to minus 1, I will get y is equal to 1. If I put x is equal to minus 2, I will get y is equal to 0. Yeah, यहाँ पे पकड़ा गया. So this value of x giving me y's value of 0. So that's why I've called x is equal to minus 2. So x is equal to minus 2, y's value is 0. So we call this as a 0 or root for this linear polynomial, which is y is equal to x plus 2. So when do we arrive at this root? Let's see a general equation for this. So general equation for a linear equation is y is equal to ax plus b. We want it to be 0 for what value of x? So put it 0, we get x is equal to minus b upon a. So this is the value of root. Now let's plot these points on the graph paper. So we have these coordinates for 3 points, x0, y2. So the point will lie somewhere here. X is 0, y is 2. X is minus 1, y is 1. So this point will be here, and x is equal to -2, y is equal to 0. Sorry for the scale of the graph, you can write at home as well. It will be fun. So we got 3 points, we join them, we get a line. So because this makes a line, we call this as a linear polynomial. So this is the reason simple equation is called linear polynomial. Let's see quadratic polynomials, its zeros and its graph. So zeros, as we saw, the roots. Let's consider the quadratic equation. Y is equal to x square minus x minus 6. So we have to keep putting different values of x to get different values of y. So let's start. Now you can try this at home. I'll do it fast. Okay. So I put x is equal to -4. You will get y is equal to 14. If I put x is equal to -3, you will get y is equal to 6. If I put x is equal to -2, I'll get y is equal to 0. If I put x is equal to -1, I'll get y is equal to -4. If I put x is equal to 1, I'll get y is equal to -6. If I put x is equal to 2, I'll get y is equal to -4. If I put x is equal to 3, I get y is equal to 0. And if I put x is equal to 4, I get y is equal to 6. So you can put any values of x and jot down some points. Now, here we have to point these points on the graph. So let's go one by one. Where will this -4, 14 will lie? So x pe -4, y pe 14. This will be here. Another point is -3, 6. So it will be here. Next point, -2, 0. So it will be somewhere here. -4, -4. Sorry, -1, -4. It will be here. Next point, 1, -6. It will be here. 2, -4. 2 from x, -4 from y. 3, 0. 4, 6. And so on. So you continue this. If you join this such all points, you will find a parabola. So quadratic equations graph is always a parabola. So for a general equation, let's say the general equation for quadratic equation is ax square plus bx plus c is equal to 0. For a general equation, you will get the graph of the quadratic polynomial is always upward facing parabola or a downward facing parabola. So when it is upward and when it is downward is decided by this a. If a is positive, then we say it is upward facing, and a is negative, we say it is a downward facing parabola. So let's have some small exercise. Now based on the graph, you have to decide nature of zeros or roots of the quadratic polynomial. So consider this graph first. Okay. Now here it is touching on x-axis of the positive side of it. So both roots will be positive. It is touching at two different points. So the roots will be both positive, both real, and both distinct or different, because it is touching at two different points. Because it is touching, it is real. It is touching on the positive side of x, it is positive. Let's see next example. Now if you see, this graph is touching one at positive side and one at negative side. So one root will be positive, another root will be negative. But because it is touching the graph, the roots will be real and different. Let's see the next example. Now if you see here, this is a downward parabola. It is touching at only one point. So that does not mean it has only one roots. Roots तो दो ही होंगे क्योंकि quadratic equation है, but both will be equal. So both roots are going to be real and are going to be equal. So एक ही जगह touch कर रहा है, that means roots are same. So यहाँ पे भी वही होगा, एक ही जगह touch कर रहा है, वो भी positive side में touch कर रहा है on the x-axis. So both roots are going to be positive, both are going to be real, and both are going to be equal. Now what if it doesn't touch like this? यहाँ पे क्या कहना है? यहाँ पे touch ही नहीं कर रहा x-axis को. इसका मतलब ये नहीं बोलते हम कि root ही नहीं है. इसका मतलब ये बोलते हैं कि root तो है, लेकिन हमारे बस के बाहर है. That means they are imaginary roots. So if the graph is not touching at all, we say the roots are imaginary. Whether it is an upward facing parabola or, like in this next example, it is a downward facing parabola. So अगर x axis को touch नहीं कर रहा है, then the roots are going to be imaginary. Okay. Now what will be the nature of root, what is product of root, what is sum of root? Based on this, we have to draw the graphs and all for the cubic as well. So keep watching our videos for the further. If you like this video, don't forget to share and subscribe. If you have any doubt, please comment in the comment box. Till then, bye bye.